and the other component is parallel to the y-axis, and that's the symbol for parallel, and this is the symbol for perpendicular. Okay, let me get my water here. I'm sorry. My allergies are horrible today, and I took a Benadryl, and I'm all dried up. Okay, so here we have an example. Draw a diagram of the given vector, then resolve the vector into its horizontal and vertical components, including direction. Okay, so here we have a magnitude of vector A is 12 units, right? So it'd be like the unit circle times 12. It'd be really long, really big circle, at a degree of 207. So it's traveling a direction of 207 degrees. Okay, so if this is 0, and this is 90, and this is 180, and this is 270. So let's see, 207. So let's subtract 207 minus 180, and let's see how far past. That's 27 degrees, right? So that'd be 27 degrees past 180 degrees. So it would be like this. Okay. So this is going to represent 207 degrees. And then this is vector A, and it is 12 units long. Okay, and so what we want to do is resolve it down into its horizontal and vertical components. So basically what I'm looking for is I want to know what is the x-coordinate, what is the y-coordinate. So I want to know, I'm going to change colors here. What is this value? And I want to know what is this value. So right now, this 180 degrees, by the way, what I want to know is what are these values? What is this vector here? And you know what? Let me be really careful to put my vectors here. So our original vector, this black vector here, is going to the left and down. So my horizontal vector is going to the left, and my vertical vector is going down. Okay, so what are its what are its magnitudes? Basically is what I'd like to know, and then I can tell it's going left and down. So what I'd really like to know here is, what does this measure? Okay, because if I have to know 3 things about a triangle to solve a triangle. And what I know right now is 2 things. I know it has a right angle because I created it by giving it the vertical and horizontal component. And I have a side. And I always need a side if I'm going to solve a triangle. So I need angle theta. So we have 207 degrees is the direction of vector A. And the distance between 180 and 207 is 27 degrees. And so there we go. All right. So here we have the opposite of 207 degrees or 27 degrees. And we have the adjacent. Okay. So if we're looking for opposite, then over here we have hypotenuse, right? Okay. So if we're looking for opposite, we're looking for sine. So I'm going to get my red pen here. So I'm going to look for the vertical component. Okay, to do that, I'm going to say, all right, so the sine of 27 degrees is equal to my y component, whatever it is, over my hypotenuse, 12. Okay, all right, so I'm going to get this out of the way here. So we multiply 12 to this side, actually, to clear the fractions. We're going to multiply times 12. So we get y is equal to 12 sine of 27. And we'll just round to the nearest tenth here. So it doesn't say, so we'll round to the nearest tenth. So we'll do 12 sine of 27. And we get y is approximately 5.44. So we're just going to say 5.4. So the vertical component has a magnitude All right, so vertical component has a magnitude of 5.4 and it's pointing down. So there's the vertical, that's the vector, 5.4 pointing down. Okay, let's do the horizontal component. The horizontal component, that would be your value of x right here, whatever that measure is right there. Okay, so that x is adjacent to angle theta, so we'd say cosine, right? Because the cosine value is the value of our x coordinate, right? So the cosine of 27 is equal to the x coordinate over 12, multiply both sides times 12. So we get x equals 12 cosine 27. So we plug that in, 12 cosine 27, and we get 10.7. So x is equal to 10.7. So the horizontal component, I'm just going to do HC for horizontal component, has a magnitude, I'm just going to do this, has a magnitude of 10.7 to the left. Okay, and so there you go. You've broken it down into its vertical component and its horizontal component. Okay, so let's take a look at this one. Vector W has a magnitude of 130 and is inclined 40 degrees with the horizontal. All right, so 40 degrees with the horizontal means that we're coming off of the positive x-axis here, so 40 degrees would probably be about right here, and this is a magnitude of 130, and this is vector W. Resolve the vector into its horizontal and its vertical component. So here's its horizontal component here. And then here is its vertical component here. So it's going right and up. Okay, and so there's our right angle there. And here's what we know. That this is 40 degrees with the horizontal. So that's that measure there. And so if we're looking for our vertical component, sorry about that, not sure what's going on there. So our vertical component, we could use, that's our y, right? So we could use the sine of 40 degrees equals y over 130, or y is equal to 130 sine 40. Plug that into the calculator. We get 83.6. So 83.6 is the magnitude and it's going up. So the vertical component, this would be vector y, has a magnitude of 83.6 and it is going in the direction. It's going up. I don't know why I have to write in the direction. It's just going up. Goes up. Okay, so there's your vertical. And then we do your horizontal and then we're done. So the horizontal component. So this is your adjacent here. So we're looking for this value of x. So we'll just call that vector x. So we're going to do the sine, not the sine. We need the cosine, right? Because it's adjacent to the angle we have. So the cosine of 40 is equal to x over the hypotenuse. So we'll multiply both sides times 130. So x is equal to 130 cosine 40. So 130 cosine 40. And that gives us 99.58. So x equals 99.6. So we could say that the horizontal component, or vector x, has a magnitude of 99.6 and goes, can't spell, goes to the right. And let's just sum that up. So all you're doing here is just using your basic trig, and you're using your knowledge of how to rotate around a coordinate plane where your positive x-axis is 0, and then you rotate up to rotate in a positive direction. And then you're just using your knowledge to determine what your angle theta is if it's greater than 90 degrees. Like for example here in number 1, to find angle theta, you had to subtract the angle given from 180 from the angle given to find the angle theta. Okay, so that's it. It's just drawing a diagram and then using sine and cosine to find your horizontal and your vertical. That's it. Okay, have a good one.